Good evening, everyone. My name is Retrieval-Augmented and this is my research project for web services. My topic today is AI agent on the web, especially how autonomous AI systems are being designed to perceive information, reason over goals, and take action on the internet with minimal human supervision. I will walk you through the key research in this area, explain the core ideas and challenges, and then present my own proposed framework called TRACE, which stands for Transparent Retrieval-Augmented Chain of to Execution. We will start with what AI agents actually are and why this topic matters right now, and then walk to the 5 main research papers I reviewed, covering the React framework, Retrieval-Augmented Generation, AutoGPT, multi-agent systems with AutoGen, web agent, benchmark, and AI safety risk. After the literature review, I will present my reflection and then propose framework that tries to improve on existing systems by prioritizing transparency and user control. We will close this implementation idea and future challenges. First, what is an AI agent? An AI agent is for Warsaw and Norvig textbook is anything that perceive its environment and act upon it to achieve a goal. For web-based AI agent, this means the agent can read web page, understand what it says, make a plan, like clicking a button or filling in a form. What makes modern AI agent different from older one is the reasoning step in the middle. Instead of following a fixed script, an AI agent uses a large language model to decide what to do next based on context. For example, you could ask an AI agent to book the cheapest flight from Newark to London in July, and without any further instruction, it would open a browser, navigate to travel sites, compare prices, fill a form, and confirm the booking. So why AI agent now? This topic is important right now because modern LLM like GPT-4 and Cloud have over 1 trillion parameters, giving them remarkable general reason ability. The AI agent market is projected to reach $47 billion by 2030. But there is a reality check. Only in 2024, only about 15% of tasks, about 15% of tasks were completed by AI agent, and human complete around 17.8%. That 14% gap is the research problem. These systems are powerful but brittle. Understand why and how to fix it is what motivates this paper. The first paper I reviewed is React, published from Princeton and Google. The key idea is surprisingly simple. Language model agent either reasoned using chain of thought prompting or hacked by predicting what action to take next, but not both at the same time. The thought action observation loop does two important things. First, it makes the agent reasoning interpretable. You can actually see why it made a decision. Second, it lets the agent recover from mistakes because it can observe that an action didn't work and adjust it next to. The second paper is Retrieval-Augmented Generation, or RAG, published by Facebook AI Research. The problem RAG solves is the large language model have a knowledge cutoff. Anything that happened after they were trained, they simply don't know. For a web agent that needs correct information, price, news, live data, this is a serious problem. To fix this problem, first, retrieve relevant document from a knowledge base or the live web, and then feeds those documents into a language model along with the question. The model generates its answer grounded in real evidence, not just memorized patterns. And now, RAG is a core building block for almost every serious AI agent. The third paper covers autonomous and multi-agent systems. AutoGPT, released on GitHub in 2023, was one of the first widely used systems to demonstrate a fully autonomous LLM agent. You give it a goal, and it breaks the goal into sub-tasks. Browse the internet, write files, run Python code, and manage it on memory, all without step-by-step instruction from a human. It was impressive, but exposed to serious limitation. The agent would frequently get stuck in infinite loops, misinterpret tools, output, and fails on tasks requiring more than 5 or 6 consecutive correct decisions. And we also have AutoGen at Microsoft that propose a different approach. Instead of one agent and trying to do everything, they use multiple specialized agents, a coder, a critic, a planner that converse with each other. The insight is that peer review between agents catches errors that a single agent would miss. But the trade-off with AutoGen is that they use many more tokens, and therefore cost is more because every decision involves multiple agents exchanging messages. The fourth paper is about WebGPT and Web Arena. The WebGPT from OpenAI use GPT-3. They use real web browser, clicking links, searching code and text, and trade it with human feedback. WebGPT was the first strong demonstration that an LLM could be trained to navigate the web, but WebGPT required expensive human feedback. The Web Arena benchmark from Zhu and colleagues at published at ECL in 2024 was designated to make evaluation systematic and reproducible. And Web Arena provides 812 realistic web tasks across real-looking platform, an e-commerce site, a social media platform, a content management system, and a code repository. But the bar chart on the right makes the problem very clear. Humans complete 78% of tasks, but the best AI agent in 2024 only manage about 15%. Every existing systems lags dramatically beyond human performance. This benchmark is my evaluation target for the proposed trace framework. The fifth paper I reviewed is by Ryan and colleagues and published in 2024. It systematically cataloged the risk of deploying language model agent on the real world. They find issue they find 4 major risks. Like an agent might send an email or delete a file without the user ever asking it to, or you ask the agent to clean up your download folder and it deletes everything, including files you needed, because deleting maximizes the cleanup objective. Third example is one agent makes a small error, and that error gets amplified as it propagates to a pipeline of agents. And the last one is prompt injection, which is malicious content on a web page tricks the agent into abandoning its original goal and following new instruction embedded in the page. And this last one is especially dangerous for web agent because the internet is an adversarial environment. Any web page the agent visits could theoretically contain an attack. These 4 risks directly motivate the design choices in my proposed trace framework. The core argument for trace is current AI agent framework are powerful but opaque. Users don't know what the agent is planning to do, what information it using, or why it took a particular action. When agents have the ability to send messages, make purchases, or modify files on your behalf, that opacity is dangerous. Trace is designed around 5 components. First one is Go decomposition layer. Second is hybrid Regis model. Third one is structure React. Fourth is permission scoping tools registry, and then the last one is audit trail UI. As example, if you ask Trace to book a flight from Newark to London, it will decompose that into 4 sub tasks: search for flights, compare prices, select a seat, and confirm booking. Trace will add evidence which document were retrieved and check which states the exact condition under which the agent should pause and ask for human input. So trace will requires the agent to explicitly declare its uncertainty before it act, not after. So why is trace better? AutoGPT and AutoGen both lack a user approval step before executing. Neither they implement permission scoping, meaning any tools can be called at any time without explicit user consent, and neither of them addresses prompt injection. The only place I would say trace is not clearly superior is token efficiency, but I would argue that a reasonable trade-off, slightly higher cost and exchange for significantly higher safety and transparency. And ultimately, trace addresses each of the 4 risk categories is identified by Ryan and Hall. For the implementation, Trade would be built in Python and JavaScript using a standard open source tools. And for evaluation, I would test on the Web Arena benchmark the same 812 tasks used to evaluate AutoGPT and AutoGen and compare task success rates directly. And before concluding, I want to be honest about trace and what trace doesn't fully solve and where the field still has major open problems. I would say prompt injection remains unsolved at a fundamental level, and long horizon reliability, and then token cost and latency are practical barriers. Evaluation benchmark like Web Arena are still simplification of real-world usage. And finally, alignment. How much autonomy should an agent have? Trace user approval model is a good starting point, but as agent become more capable, the question of when to defer to human versus when to act become increasingly complex. To wrap up, AI agent represent the next major shift in how software interact with the internet. They move us from passive information retrieval to active goal execution on behalf users. The research I reviewed showed that foundation are solid, but the reliability and safety gaps are large. Current agents succeed on fewer than 15% of realistic web tasks. My proposed trace framework addresses the most critical gaps, goals, misalignment, unintended side effect, and prompt injection by making every step of the agent reasoning visible and controllable by the user. I believe transparency is not a limitation on agent capability. It is a prerequisite for user trust and therefore for real-world adoption. Thank you for watching.